Alright, welcome to the Magnets and Magnetic Fields Notes review. It's going to be a two-part magnet video review. First part just going to be over basic things about magnets and how magnetic fields are formed, and the second part will be electromagnets. I suggest you watch it as well. Alright, let's go ahead and get into it. What is the magnetic force? It's a force a magnet can exert on another magnet. Push or pull that it can, exert onto another, what's classified as a magnet. Iron or similar material or other moving charges. It can push or pull things, so therefore it's classified as a force. Some of the stuff's pretty basic, I assume you know it. All magnets have two magnetic poles, the north and the south, where the magnet's force is the strongest. Like magnetic poles repel, unlike magnetic poles attract. If you'll remember back to electricity, this is the exact same rationale behind the electricity unit. Negatives and negatives repel, positives and positives repel, and then positive negative attract. So it's just like electricity in that sense. This is a more concrete example of that happening, as you can see a magnet a lot more easily than you can see a electron. So what is a magnetic field? Well, it's just like the electric field. It's an area surrounding a magnet that can exert a magnetic force. And exactly like a electric field, it kind of loops around to the other end. Strength is always stronger at the poles or closer to the source here, and then it kind of weakens as it goes out. Just like electricity, just like gravity. These are things that you're very familiar with. Distance increases, the strength of it decreases. The magnetic field around the Earth is known as the magnetosphere. Earth is basically a giant magnet. It creates a giant magnetic field that extends into space. The reason that the Earth is like a magnet is the core. The core is iron and nickel, probably some cobalt too. And as the Earth turns, it's creating a magnetic field because the metal inside the Earth is also turning or moving. Only three different things are magnetic. Three metals. They're collectively called ferromagnetic materials. And those three things are iron, nickel, and cobalt. If you remember, the prefix ferro means ferrous or iron-like. That's where we get the atomic symbol Fe on the periodic table. So only these three things are magnetic. Aluminum is not magnetic. Copper is not magnetic. Most metals are not magnetic, contrary to popular belief. Titanium is not magnetic. Sodium is not magnetic. So only these three things, or alloys of these three things. The magnetic domain is the region around, region within a magnet that has a very large number of atoms with aligned magnetic fields. Now, what does that really mean? Well, the magnetic fields north to south are aligning up together in those regions. When a material is magnetized, most of its magnetic domains are aligned. Now here you can see in the example, this might be a ferromagnetic material, like a nail or something like that. But the domains, which are these little areas here, basically think about them as clumps of atoms that are lined up positive to negative, but they're not all together. They're, within each region they are aligned, but because there's so many regions that kind of go every which way, does not show magnetic force. When something is magnetized, you have, all the arrows pointing in the same direction. That's what a domain is. The domain is the small little area that makes up one small part of a magnet. When you have all these parts working together, that's what makes a magnet. All right, we'll stop here for that. That's just kind of real basic magnet review, magnetic field and magnetic domain review. Like I said, there's going to be another video on electromagnets. I suggest you watch it as well. All right, I'll see you in class.